Hello everyone. The topic of our today's class is connecting devices. Let's see what connecting devices are. In a communication network, hosts and networks do not normally operate in isolation. So we use connecting devices to connect hosts together to make a network, or to connect networks together to make an internet. And the connecting devices can operate in different layers of the internet model. This is the internet model, and we have these three types of connecting devices. We have hub in the physical layer, that is the first layer of the TCP/IP model. And next we have the link layer switches, which operates in the second layer, that is the data link layer. And third, we have the router that operates in all these first three layers, that is physical, data link, and network layer. And the second one, data link layer switches, operates in not just the data link layer, but both the physical layer and the data link layer. First, let's see hubs. As we have mentioned earlier, the hubs, they only operate in the first layer, that is the physical layer. So in a communication network, signals that carry information within a network can travel a fixed distance before attenuation. Here, attenuation, what is meant by attenuation? Let's see. Attenuation is the loss of signal strength in networking. So this attenuation may cause signals to become distorted or indiscernible. And some of the reasons why this attenuation is usually caused is mainly the noise. When we say noise, it means interference like radio frequencies, electrical currents, or wire leakage, etc. And the more noise we have, the more attenuation will be experienced. So in order to solve this problem, repeaters are usually brought in. Let's see what a repeater does. A repeater receives a signal, and before it becomes too weak or corrupted, it regenerates and retains the original bit pattern. Then the repeater sends the refreshed signal. So here, this repeater tries to solve the problem of this attenuation. Before, in the past, when Ethernet LANs were only using the bus topology, let's see the different network topology here. Yes. Before, when Ethernet LANs were using the bus topology, a repeater was used only to connect two segments of a LAN to overcome the LAN restriction of the coaxial cable. But today, Ethernet LANs use star topology. That is the second one. So in a star topology, a repeater is a multiple port device, which is called a hub. So a hub is nothing but a multi-port repeater, or a hub is nothing but a repeater which has a multi-port device. So a hub can be used to serve as the connecting point and at the same time function as a repeater. Let's see an example of a hub. Here, this is an example of a hub. In this example, it shows that when a packet from station A, this is the station A, to station B arrives at the hub, the signal representing the frame is regenerated to remove any possible corrupting noise, but the hub forwards the packet from all outgoing ports except the one from which the signal was received. So here, since a frame is sent from A, this is the point where A is connected to the hub, and the other points are these are the points that connects the other networks. So here, in other words, we can say that the frame is being broadcasted. So here, all the stations in the LAN will receive the frame, but only station B keeps it, and the rest of the stations will discard it. Since the frame is meant for station B, so what the hub will do is it will broadcast the frame to all the devices, that is B, C and D, except A, because since the frame comes from A, the hub will not send back the frame to this port where the connection is with A, but it will send the frame to all the other devices, and only B will keep it, and the rest of them will discard the frame as the frame is not meant for them. So this shows that a hub does not have a filtering capacity or it does not have the intelligence to find from which port or frame should be sent out. And as a hub or a repeater is a physical layer device, they do not have a link layer address, and they do not check the link layer address of the received frame. So what a hub does is nothing but just to regenerate the corrupted bits and send them out from every port. Let's come to the next type of connecting device, that is the link layer switch or link layer switches. A link layer switch operates in both the physical layer and the data link layers. So as a physical layer device, it regenerates the signal it receives, and as a link layer device, the link layer switch can check the MAC addresses, that is source and destination, contained in the frame. And one of the main difference of a link layer switch from a hub is its filtering capacity. A link layer switch has a filtering capacity, which means that it can check the destination address of the frame, and it can decide from which outgoing port the frame should be sent, which is not the case with the hubs. This is an example of a switch. Here we have a LAN with 4 stations that are connected to a link layer switch. So here, if a frame destined for station 71:2B to 13:45 61 42 arrives at port 1, then Here, the link layer switch will consult its table to find the departing port. This is the table, switching table. So, according to its table, the set frame, that is this one, this particular frame should be sent only through the port number 2. What happened in hub earlier was it forwards the frame to all the stations, but here, since it has the capacity of consulting the routing table and it has filtering capacity, so here it can check the source and destination address, and it will send only to the port to which that particular station is connected. So here this frame will be sent only through port 2, and there is no need for forwarding the frame through other ports. Let's see some advantages of the switches over hubs. The first advantage is collision elimination. A link layer switch eliminates collision. This means that increasing the average bandwidth available to a host in the network. In a switch LAN, there is no need for carrier sensing and collision detection, so its host can transmit at any time. And the second advantage of switches over hub is its capability of connecting heterogeneous devices. This means that a link layer switch can connect devices that use different protocols at the physical layer and different transmission media. So as long as the format of the frame at the data link layer does not change, a switch can receive a frame from a device that uses, for example, twisted pair cable and sends data at 10 Mbps and deliver the frame to another device that uses, for example, the fiber optic cable and can receive data at 100 Mbps. Coming to the third type, that is the routers. A router is a 3-layer device. That means it operates in the physical layer, data link layers, and the network layers. And as a physical layer device, again it regenerates the signal it receives, and as a link layer device, the router checks the physical addresses, that is source and destination, contained in the packet, and as a network layer device, a router can check the network layer addresses. So this means that a router can connect networks, or in other words, a router is an inter-networking device, and it connects independent networks to form an inter-network. So according to this very definition, we can say that two networks connected by a router becomes an inter-network, or simply an internet. Let's see an example of routing. Here, in this particular example, let's just assume that an organization has 2 separate buildings with a gigabit Ethernet LAN installed in each building. So, the organization uses switches in its LAN, and these 2 LANs can be connected to form a larger LAN using 10 gigabit Ethernet technology in order to speed up the connection to the Ethernet and the connection to the organization server. So this can be made possible by the router. So a router can connect the whole system to the internet. And let's see some differences between a router and a switch, or in other words, we can also say the advantages that routers have over switches or the hubs. First, a router has a physical and logical address for each of its interfaces. And the second is, a router acts only on those packets in which the link layer destination addresses matches the address of the interface at which the packet arrives. And the third one, a router changes the link layer address of the packet, both source and destination, when it forwards the packet. So all these qualities, let's say, of a router is not contained by the switch or the